So, very good morning to all of you. And this is the second webinar we are having in the monthly webinar series. And today we have Lieutenant General Anil Kapoor, who is very supportive of all the activities of AMSI, very passionate about what we are doing. And I extend a very warm welcome to Lieutenant General Anil Kapoor on behalf of all of us, as well as Asset Management Society India. A very warm welcome to all our members this morning. Although we are very few, but we certainly will improve the numbers as we move forward with some of these outstanding lectures, which will also go on YouTube, and hopefully we will have more people joining these webinars. And welcome again to all of you. I request Ms. Mahua Banerjee to introduce our guest this morning.
Thank you, sir. Good morning, everyone. So, Lieutenant General Anil Kapoor Ati Vishisht Seva Medal and Vishisht Seva Medal, superannuated as Director General Electronics and Mechanical Engineering on 31st December 2020. The General is an alumni of the prestigious National Defence Academy Pune, Indian Military Academy Dehradun, Defence Services Staff College Wellington, Army War College MHOW, and National Defence College New Delhi. A gold medalist both in BTech Electronics and Master of Engineering Mechanic, MSc in Defence Studies, Master of Philosophy in Strategic Management of Technology, and is an expert in radars, guided missiles, MRO asset management, and condition based monitoring of assets. He is presently pursuing his PhD and has submitted his thesis on defense industrial base as a key determinant of capability building and capacity development of India. The 4 decades long journey that followed in military services bears testimony to maturation of his experience in military leadership, technology and innovation management, equipment management, change management, organizational behavior, ingenious administration, and human resource management in diverse and challenging environments. The General has also been Director General Information Systems, been on 2 United Nations peacekeeping assignments as Senior Logistic Officer in Angola and Deputy Chief Integrated Support Services in Sudan on deputation to UN for 2 years. He also managed operational logistics in Jammu and Kashmir, Operation Vijay during the Kargil War, Operation Parakram, and recently engineering support planning for Operation Snow Leopard in eastern Ladakh in 2020. As a brigadier, I'm sorry, as a brigadier, he was Dean of Faculty of Industrial Engineering and Tactics in Military College of EME and as a Major General EME in Northern Command. He implemented engineering support philosophy and practices, which has become a best practice in the corps of EME. The general was awarded Ati Vishisht Seva Medal on 26 January 2020 and also the Vishisht Seva Medal on 26 January 2004 by the President of India for rendering distinguished services of an exceptional order and General Officer Commanding in Chief Central Command Commendation for displaying outstanding professionalism, technical brilliance beyond the call of duty. A chartered engineer, he was also awarded the Eminent Engineer Award 2020 on 15 September 2020 by Institution of Engineers India for outstanding professional contributions in engineering and displaying technical brilliance. He is a master class independent director and member of Institute of Directors and Indian Institute for of Corporate Affairs. He is also the Vice President and Chair of the National Advisory Committee of Asset Management Society India. So we are very lucky to have you, sir, today, and kindly enlighten us with your talk. And we are very eager to listen to your talk today. So please, sir.
Thank you very much, Professor Pai, and thank you, Mahua, for the introduction. Just a little clarification. I've defended my thesis and I've been a doctorate for over a year now. Okay. It's
Congratulations,
indeed,
sir.
thank you. It is indeed interesting to talk on,
Congratulations.
thank you, talk on asset management 5.0. And why did I name it 5.0 is because industrial management 4.0 is actually into huge advancements from the time we know the tone and texture of industrial revolution 4.0 and the way it is panning out given the technology spectrum. So today, the intention is to look at the future of asset management, which I call asset management 5.0, and look at the pillars and examine in times to come how should the governments, the industry, the academia, and the agencies like CII, FICCI, SOCHM, and others should look at the next gen asset management because it is going to disrupt the future. So let me start with the basics since some of the attendees uh, would actually like to recap a few of the aspects of asset management which are changing with time. So when we look at an engineering asset, it could be a hardware, it could be a digital asset, that means a e-asset, which would have, which would be known either as a QR code, which is based on optical scanning, or a RFID, which is based on radio frequency. And further, it could be an active RFID or a passive RFID. But it, and then today you have softwares, you have applications, you have software-based systems. That is also an asset. And you have software as a service, hardware as a service, platform as a service, infrastructure as a service, which is also an asset in the organizational interest. So really speaking, the definition of an asset, when we club a lot of technologies and pack a technology stack, is changing depending on the technology stack. Now let me look at, just for the sake of an example, an enterprise, which is infrastructure as a service. Now there is a sensor which is turning out data. So let's look at a gearbox with a number of sensors, and that becomes the single source of truth, or SSOT as we say. And this data actually is humongous, and we'll see it a little later how huge the data can get. It gets into a server or a data center from where uh, from this server it enters into a cloud, and we've been hearing about cloud computing. And once this data is in the cloud, there is an access control which is administered. And when you have access control through varying service providers, they act on that data and give relevant outputs to application clients. So that in effect is the journey of infrastructure as a service. And this in effect is an enterprise in itself, and in other words, an asset. So when we look at an engineering asset, therefore, it could be a hardware, it could be a digital hardware, it could be a software, it could be a service. So this is the broad definition when we say an asset as it pertains to asset management 5.0. Now, we've always known that asset management is essential, and some say it is desirable, but I would say when it comes to asset management 5.0, it is vital. It is like oxygen. I mean, if you're breathing and you don't get oxygen for a quantifiable amount of time, which may be in some cases even up to a minute or two, you could It could kill you. You could die of it. And therefore, I think in times to come, asset management is going to become so vital that if we did not incorporate it as a strategy, uh, we would be facing uh, a near death of that mission, of that enterprise, of that corporate house or the industry, as the case may be. So, really speaking, it is very important that in times to come, as much as it was in the past, we ensure that the right asset is at the right place, at the right time, in the right condition, in the right quantity, at the right cost, and we can keep adding any more rights which we are able to incorporate by virtue of technology. Every organization has objectives, vision, mission, methods. I think asset management must form part of this, and there is a need to set goals, key related activities, key performance indicators, and as we go along, we will see what are these goals when we look at asset management 5.0. There is a need to define some terms of reference in asset management. We have these ISO standards, ISO 55,000, 55,001, 55,002, 27,000. But I think there is a need to now rethink on these and be dynamic about them. And I would propose as I go along a unified ISO standard when we look at asset management 5.0. Also, it is important to see how do you shape the battlefield. When I say battlefield, an asset is a small baby component right through till a car or any other product that we may have on mind. And therefore, you have to shape your industry, you have to shape your market, you have to shape your customers, you have to shape your life cycle support, and all that requires asset arena shaping. And I call it asset arena because depending on the situation, depending on the time, depending on the space, the arena could change. And therefore, what, when, where, how is very important as we add it to this why. And of course, one more is who. And we'll talk of it towards the end as to who would do this for optimum and efficient asset management and condition monitoring for a reliable predictive maintenance. So that is one more vital reason why asset management is vital. Also, today's time, mission readiness is critical. I mean, let's look at the Ukraine war or what Israel is doing or any other corporate endeavor. If you define a mission has an activity and a timeline. It has a work time plan. So it is a time bound activity. And if in that time bound activity, given the boundary condition of the myriad of activities that one is required to do, the performance that is expected, and the sustainability and reliability that is expected during the mission, if it is not met, I think it could be suicidal for that mission. And therefore, it is very important to build asset management practices, which gives you visibility and assurance of success when you look at mission readiness. And one more reason, principal reason is enterprise readiness. If you would like to know, are you ready for the future? How do you make sure you're ready? And I've coined a term, enterprise readiness index. How does an enterprise look at its readiness index? And I mean, these are terms which may not be there in a common jargon, and but we will develop them as we go along today, and maybe as we move along ahead as Asset Management Society India. Now, let me look at the enterprise asset readiness and do a little scenario building. Now, a scenario building for Asset Management 5.0. I've been saying this and I continue to say that the new tech world order is defined by 4 Ds: data, digitization, digitalization, and disruption. And I think one very big disruption which is coming very soon is quantum. And therefore, if we were to look at the technology stack, we look at IoT and sensors. And when I say IoT, it's actually Internet of Everything. We look at geospatial technologies. We look at big data, cloud, and AI platforms, augmented virtual realities, blockchain, then we'll talk a little ahead. Quantum technologies I just spoke about, digital twins, nanomaterials, nano energizers, nanotech, infrastructure as a service. And therefore, when we look at this technology stack, four very prominent terms come up which are very relevant when you look at asset management 5.0. The first is automation. And that we have seen is already happened. And we've seen the benefits of automation. We've seen how digital public infrastructure in India has made a difference right through to the last mile, and how India, as a digital India program, is becoming envy of the whole world. And today, the world wants to get to India to understand how we did it, how our digital journey was, and actually want to emulate it. So really, automation is a huge enabler. We've seen how it integrates the nation mainstream into technology, or through technology into if I may say, a collective economy with huge visibility. The next step is going to be autonomy. And when we say autonomy, decision making is inherent. So it could be either a totally autonomous system where we design a system in a manner that it takes inputs, goes through the cycle of iterations, and does effective decision making. Or it could be semi-autonomous where man is in the loop and we look at what is called augmented intelligence. So while automation gave us business intelligence, autonomy gives us augmented intelligence or predictive intelligence into the future and helps us in decision making. And then we have a term, precision and positioning. Today, it is all about precision. That means given the nano reach that we've achieved in everything, and we continue to go lower down in the rung in terms of time. Uh, and therefore, on the one hand, and on the other hand, we are having terabytes and petabytes of data. There's huge amount of data. So both this put together actually result in precision. And if we look at this as one of the key enablers, the other is positioning. I mean, and Google Map is a very good example of automation, autonomy, precision, and positioning. I'm sorry, I'm calling it Google Map, but I think since all of us understand the nuance of this Google initiative and Google enterprise, I think it's a great example to learn out of, that any asset, whether it is a petrol pump, restaurant, or anything that is logged into the map as an asset, has full visibility, and you could deep dive into it to get whatever information you want. Therefore, that said, the future of asset management 5.0, what can it give you? It can give you the visibility right through till the last mile, which we call the edge. You can track precisely and uh, know the position picks in a 3D space of everything that is there, which is so important when you look at any enterprise that you'd like to get into. There are a large number of platforms, large number of sensors, and therefore looking at the same space. Therefore, multi-platform, multi-sensor data fusion must become part of asset management 5.0 strategy. Given the humongous amount of data loggers and a cloud at the other end would be the next important requirement. And of course, when you have large data analytics, and a dashboard to give a user-friendly uh, way of depicting for a user or a consumer would be very important. We've always been used to a periodic or a preventive maintenance schedule based on some data. Today, technology allows you to get into a predictive and a prescriptive analytics through data, and therefore that will be one more very important determinant or very important driver of asset management 5.0. And all this put together, it gives you a very involved and a very intense decision support system for asset readiness. And therefore, what we look at is there is a need to humanize assets, like I say, using technology. You have to look at system engineering complexities and reduce them as much as it can be to make it user friendly. Uh, we have time has come for condition monitoring and maintenance systems using these technologies. And I'm sure a lot is happening, but a lot more has to happen. And then we look at two T's. Sorry, a technology, which is software, and data, which is software driven. Sorry, technology, which is semiconductor driven, and data, which is software driven. So really speaking, the whole space of production of ROI is enabled by technology and data, which is semiconductor and software. So that is also the reason why we are going in for, or globally, there is a huge push to mission semiconductor. There's a huge push to mission quantum, because when you have to compute so much, it becomes a huge challenge. And therefore, the bigger play around in asset management 5.0 is about semiconductors and softwares. Okay, let's move on. Now, just a few thoughts on what is asset management 5.0. So it's a holistic technology scenario, which is a data-driven enterprise approach to asset management. And we talked of 4Ds. So really speaking, every asset, whether it is a photograph, video, text, or audio, is an e-asset, which can be defined, if I may say, by zeros and ones. And these digital assets in some form are structured. They could be held in a centralized format or a decentralized format into a cloud. And when I say decentralized, it is because the cloud itself may comprise a number of data centers, and therefore to that extent it could be decentralized. But in some way it is centralized because everybody can access a single window way of doing things. It's collaborative, and there is huge amount of access control, huge amount of tracking. Because like we all say, today's time is all about cybertronics. And therefore it's very important when we look at a digital asset, we look at collaboration, sharing, access control, tracking, all in a very secure environment. And then there is integration with tools. A lot of tools would be required for automation, autonomy, enterprise resource planning, project management, and many more tools which will keep getting added on to whatever the inventory of today exists. And then there is a need to get a visibility over the condition of the asset, whether it is useful or it is degraded. And if it is degraded, we need to do something about it. If it is in use, can it be reused? Can it be recycled? And of course, if we were to look at which asset is where, we could get to know the quantity and quality. So that is the reach, which could include even supply chain, inventory management, all that when we look at asset management 5.0. And as we move on, it'll become further clear as to what and how do we do it. Now, one very important aspect when we look at asset management 5.0, which will become, today it's a choice, tomorrow it will become a compulsion, is blockchain. Now, when we look at blockchain, there are three key things. One is it is decentralized. Second, it is peer-to-peer. Third, it is a distributed ledger technology with immutable ownership. So to explain it simply, let's look at the two diagrams below. Let's look at to the diagram to the left. We have 6 nodes with 6 ledgers, all interconnected. So really speaking, the data is held in 6 nodes and in 6 ledgers in a format which is peer-to-peer, distributed. And why is it immutable? Now, let me explain this through the numbers that are written to the right. Now, let's picture in our minds, since mechanically we understand things much better, since sometimes electronically and conceptually it is a challenge. Let's look at a non-return delivery valve, what we call the NRD valve. In NRD valve, anything that moves forward cannot be pulled back. So really speaking, in blockchain, we have these hashes. So if your first data set is hash 1, the second chain will be, if it is next data point is 2, it will be hash 1, 2. And the third one in the chain will be hash 1, 2, 3. So as you keep adding to the blocks, you actually are adding what was there earlier. That means one, then it becomes one, two, then it becomes one, two, three. And there's only a mathematical way or a physical way of explaining it. And therefore, what happens is it becomes immutable because whatever is gone in, you can neither erase it nor can you remove it. It's a non-return delivery valve. So digitally speaking, you cannot do anything because it's already put in. From a physical point of view, it is like supply chain. Imagine a supply chain moving and you say, well, the truck has left Delhi, it is entering Noida, it is now entering Greater Noida, it is entering Ghaziabad. So as you keep saying this, actually, it is all getting recorded and into a non uh, erasable fashion. That means whatever is put in, whatever it is physically executed, is physically recorded. So, to that extent, blockchain in actual forms of data management, of asset management, is actually something which is a ready record of truths. It becomes a single sort of source of truth. And more importantly, it has the full record end to end. So that is why I personally feel that sooner than later, every industry will have to embrace it as, and it will become a very important component of asset management 5.0. Then there's something which again I'd like to coin is a quantum asset management. So there's going to be a, like the digital world is going to transform into a quantum driven world. Digital asset management is going to get into quantum asset management. And when we say quantum asset management, it is still a data driven approach, except that it is advanced technologies and more importantly, a technology driven enterprise asset management. And when we look at this integration of sensors, IoT, we're looking at smart technologies which are going to develop with time, and all of them will get incorporated. We've looked at an example of infrastructure as a service, software as a service, platform as a service, and therefore it will be automation to autonomy and um, asset to asset, in which in this automation to autonomy, the various combinations that we can look at is asset to grid, asset to network, and asset to infrastructure. So we can go on again that everything will be talking to each other. An asset will be talking to another asset. An asset will be talking to the grid. And that is also the philosophy of digitized assets or humanized assets, as I'd like to call them. And therefore, the data-driven decision making will become uh, the hallmark of asset management 5.0. And when we look at data-driven decision making in a autonomous mode, either semi-autonomous or fully autonomous, life cycle sustenance support is going to get hugely facilitated through a predictive prescriptive maintenance model. So the reliability is going to get the next, if I may say, kick in its apogee, where from periodic preventive, we're getting into predictive prescriptive kind of maintenance. And when we look at this prescriptive, predictive, we are looking at just in time maintenance. We are looking at minimum downtime. We're looking at planned, scheduled maintenance. And therefore, obviously, it will build in efficiency, optimization, effectiveness. Because when we look at asset life cycle, MRO and life cycle maintenance board is a very important factor in it. Then today, in a digital world where everything is held as data, uh, this virtual creation of asset through simulation and digital twins is perhaps the best way forward. iPhones that we hold in our hand, the Apple has got a digital twin of whatever we have. The beauty of digital twin is that if you get a feedback from the environment, from the real world, that these are the problems, those problems can be put into the virtual mode in the digital twin to come up with robust solutions which can look at either product improvement or a new product which has those problems removed. So really, that is going to be the new normal, which most industries, it's already a compulsion if they have not done it. Very soon, if they don't do it still, it'll become crisis for them. So industries which have to survive, we have to look at digital twins as a inevitable need for the assets that they produce or products that they produce. And then Today, given the thrust on ESG, climate change, and the awareness that is developing globally, more important than awareness is the concern that is developing globally. Sustainable and environmental considerations will become very important. People will question those industries which produce greenhouse gases in a zero emission environment, and therefore industries have to look at safer, cleaner practices, clean manufacturing, and that becomes part of the asset management 5.0 strategy, and therefore risk management around ESG will become very important. While we did all this, and given the speed that quantum is going to bring, and with speed comes the huge amount of data that can get easily accessed, I think competitive business intelligence is going to be a very important factor in asset management 5.0, because the survivability of business in such a competitive environment will need a full wing or a full thought into how does competition and complementing also get into the shape of things to come. Okay, more of it if there are any questions. Now, let me get to the pillars of the what that we have talked of. We talked of what is asset management 5.0, how do we do it? And I'd like to look at enterprise asset management through 7 pillars. The pillar one, I would say, is technology on one end, which is semiconductors, and data on the other, which is software. Now, the enablers are sensors and IoT. When there is sensor, a large number of sensors get into a system, you need electronic control units, which can control these sensors exactly like a human body. You've got so many organs, they got so many nerves, and but there is a methodology in the madness. There's a circulatory system, there's a respiratory system, there's a endocrine system, and therefore each of these systems, given the number of sensors in the body, can be looked at as ECUs, electronic control units. So really speaking, any asset today would have sensors, would have IoT enabled, either active or passive, and ECUs. And therefore, the need will be to do, since huge amount of data gets generated, you have to look at data privacy, you have to look at data integrity, and therefore you have to look at a data governance structures will have to be built in as a part of this goal. And we need to look at big data analytics. Uh, we have to look at communication, and it could be wired communication protocols or wireless communication protocols, including Bluetooth. Then we'll have to look at generation of a lot of software, and we'll look at an example ahead, and a cloud where data gets centrally stored. So really speaking, when we look at the first goal for enterprises for an enterprise asset management strategy 5.0, the first goal is enhancing technical thresholds. So all enterprises would do well to enhance their technical thresholds using the technologies. Now, whatever we've spoken till now, let's walk through this pillar one. Now, today, a large number of sensors are available, and you name a requirement, you name a capability that you need, there is a sensor available. If it is acoustics, there's acoustic and noise sensor. If there is light, there's a LDR sensor. If there's smoke, there's temperature. So there are sensors available for everything. And if you look at any rotating systems, I think one of the very important sensors which has been in existence but getting improved with time is the torsion vibration sensor. I'd like to spend a minute to explain this. Look at a torsion vibration sensor which is embedded with a flywheel, and it reads from the flywheel when the flywheel rotates. Now, suppose there are 100 teeth in the flywheel and it is rotating at 1000 RPM. And also look at a vibration sensor which picks up these data. And if we were to look at a torsion vibration equation, which is a differential equation, let's look at the first 6 harmonics from every teeth. So from every teeth, the data picks up 6 harmonics. That means in one full revolution of the wheel, it picks up 600 pieces of data. And if this wheel were rotating at 1000 RPM, then you're getting 6 lakh pieces of data every minute. Now, if this wheel were rotating for an hour, you can imagine the amount of data, almost 36 million pieces of data is getting churned out every hour. Is it possible for a human being to really look at what is happening? Obviously not. And therefore, the need for data loggers, the need for cloud automatically manifests because, I mean, these data is supposed to be maintained over years, and we just talked of 1 hour. And to a user, the data means nothing unless it is put on a dashboard. So look at this dashboard. It gives you green zones, amber zones, which are warning zones, and red zones, which are zones of criticality. So in an overall analysis, today's systems will be a combination of hardware and software, and we largely will call them software design defined systems because hardware has always been in existence. What is now changing is the software value add. Okay. And if we were to take this analogy further, if you look at now, you can actually look at the continuum that there is a blue zone, which is the zone for future planning, where a lot more planning can and must happen, and that is the R&D space of industries. You have the green zone, which is the zone of safe operations. You have the amber zone, which will raise flags that you need to maintain, and red zone, which will tell you criticality is imminent, and if you don't take action now, there'll be a breakdown. So really speaking, the asset is talking to tell you where is it blue, where is it green, where is it amber, and where it is red. And therefore, you have to avoid catastrophes, do condition monitoring. It is very much doable. Okay. Now, if I were to take a car, which most of us understand, look at the amount of sensors that go into it. Now, the sensors are almost maybe 1,000 sensors or more are possible, and they are put into something called the ECUs, the electronic control units. You could have anything from 80 to 150 electronic control units, and the numbers would increase as we look at more and more autonomy. You have a wired system with protocols, you have a wireless system with protocols. And just to give you an example, in one of the cars which we studied, the complete harness was almost 10 kilometers long, which would weigh anything from 50 to 100 kgs. So that is the kind of weight that wired system bring in, but today wireless is possible. Now this is how a car would look. I mean, every system has a ECU, which is just on a PCB with a number of ICs, and you could have advanced driver assistance system, ADAS, ECM engine control module, braking control module, powertrain module, vehicle control module, body control module, infotainment. So, I mean, these ECUs are also increasing based on the needs. And if you were to now look at the vehicle from a top view, you have a vehicle which has zones. So let's look at the diagram. So there are two central ECUs which talk to each other, and each of them controls a number of zones. So really speaking, if you were to now label your human body with a number of systems and any system, any asset, you will be able to draw a replica of zonal controls and central controls. And when we look at it from a hardware perspective and a software perspective, you've got radars, you've got sensors, you've got domain controllers, and you've got softwares which are service-oriented gateways. And just for the sake of an example, if I were to pick up a main battle tank or any tank, we've coined a term called shape to read the whole tank. You have a suspension, you have a hull, you have an armament and turret, you have a power pack, and you have electronics. And if you were to able to monitor all of them through a, a a semiconductor software combination, you could actually define the shape of things to come in terms of reliability by reading it through a software defined system. So this is the way asset management 5.0 is progressing today and in the foreseeable future. Now, when we look at a software defined system, I'm going a little bit more into technology because it's good to understand there are 5 key things we must understand. The hardware and functionality. Do you need i5? Do you need i7? Do you need i50? So what is the hardware which is going to support? Do you need a GPU? So that is a decision. What is the kind of architecture, software architecture? What are the kind of standardization? What is the kind of security and safety you want to build into the system? And how would the software get upgraded? How do you keep the system agile? So these are going to be some of the determinants when we look at software defined systems in asset management 5.0. And if we were to look at the lines of code, just for the sake of an understanding, a Boeing 787, which is a next gen, has about 15 million lines of code. A space shuttle has about 1 million lines of code, but a high-end car could have as much as 200 million lines of code. So depending on the autonomy that you need, and I'm talking when I say 200 million lines, it is a driverless car on a busy road. So depending on the complexity, the number of the software footprint would vary. Okay. So getting back to our goal on enhancing technical thresholds, we looked at the first part. The second set of technologies would be for precision and positioning, which will comprise your geospatial technology and asset management information decision support systems, which gives you BI, augmented or artificial intelligence, predictive analytics, blockchain. We've looked at uh, how it becomes important when we look at large amount of data to build transparency and also ensure that there is your risks are minimized and mitigated, and it's a secure way of uh, doing business. Cybertronics, which is cyber security and electronic security, is both very important because you have to look at EMI, EMC, and any deliberate jamming or phishing operations in your electronics and in the cyber domain. And then the future is about smart manufacturing. You have to look at BAM, you have to look at 3D printing, and this is again developing in a very big way, both in terms of uh, creating technology. It is additive manufacturing. The lathes are going out because there are a lot of waste that gets generated when you look at uh, lathe machines and that those associated operations. But when you look at future, additive manufacturing is the norm, and therefore that is where the new future is, with, laced with a huge amount of surface finish, which is also a technology in itself. And then let's get to the second pillar. The second pillar of asset management 5.0 is the manpower, the skilled manpower. And here there's a need to enhance technical thresholds of this manpower as a continuum. It is about continuous learning. So in India, we have the demographic dividend, which is a global envy. I think we are a population, youth population of about 700 million. And just to give you an equivalence, the population of America is 350 million. So our youth itself is twice the population of America. And therefore, for us, and even as asset management 5.0 globally, skill is the new collar. I think we need to keep learning, unlearning and relearning and re-evolving ourselves with new skills. Entrepreneurship has become a norm and will continue to be so. Then we'll have to have OEM certified. The original equipment manufacturer will have to build standards now to certify operators, to certify maintenance agencies and grade them that he's a A grade mechanic, he's a B grade operator, he's a C grade technician or whatever. And then we'll have to build in service providers. So these few individuals actually could become certified service providers with well-defined SLAs. We'll have to build in certification and compliances. We'll have to look at training. Training has to be lifelong, like I said. Um, Subject matter experts will be required. So train the trainer. Who will certify whom? I mean, an OEM obviously cannot take the responsibility of certifying globally. And therefore, we'll have to look at certifying subject matter experts. That's going to be the new normal. And upskilling and reskilling will be very important to ensure that we have something which we call creative problem solving. So when we look at enhancing technical thresholds through skilled manpower, I think specialization will be the new need, and we'll have to look at it very, very deliberately. When we say we, all those dealing with asset management 5.0, be it industry, be it government, be it any other agency. The next pillar is infrastructure, and the goal here would be to upgrade and modernize technical infrastructure. Gone are the days when you could look at upgrades happening once in a while. I think given the disruptions that are happening, upgrade and modernization will have to form part of a regular strategy. I talked of industrial automation to industrial autonomy. There's a big shift happening. And let me, okay, I'll walk you through a little later through this, through one of the industries which is developing this or has developed it to quite an extent. We'll have to look at flexible multi-utility shop floors, and we will see some of these. Production and ROI will get linked to modernization with time. As much you upgrade and modernize, in the long run, you gain on productivity and ROI. You handle surge better, you handle quality assurance, quality control better. So really, that is going to be embedded given the technology thresholds that we've looked at. Robo-based smart additive manufacturing, 3D printing will be very important. Now, in some cases, industries will have to look at mobile containers with 3D printers, which is my mobile workshop floor, which is my mobile industry. I think that's going to be yet another new norm, which is going to come up with time. Since I talked of earlier also, ESG is going to be very important. Clean, green technology manufacturing and energy efficient systems will have to be built in. I mean, there was a time smoke was accepted and we had most of the industries giving a lot of smoke. And then there was a legislation, there'll be no smoke, and we found no smoke happening. In cars, we had a lot of exhaust coming, and then we brought in catalytic converters to reduce the amount of uh, effluence that was coming out, which would pollute the environment. So really, this is going to be yet another upgrade and modernize parameter. Supply chain resilience will be very important. Even today, everybody wants to know where is a particular asset at every point in time till it reaches the door. So the door-to-door visibility is very important, will continue to be. And cyber security, I've talked of. Okay, so therefore, in an overall analysis, when we look at upgrade and modernize, we have to look at a continuous improvement in infrastructure and infrastructure that is adaptive. Now, let me walk you through the Volkswagen bubble factory at Dresden, Germany. Now, look at this shop floor. You will find when you actually go in that there is a structure which is on the roof of the floor, which is adaptive, which can be moved, and also on the floor, which can be moved and adapted based on the need. So this is a shop floor which is so adaptive that it can take a surge of, say, if the ambient capacity is 20, you could actually readjust everything to take it up to 100 as an example. So it is so adaptive. Similarly, what is there on the top can get incrementally added or multitask to do so many things. So when you walk through this factory, you actually get a look and feel of what we look at infrastructure into the future. A lot of value addition keeps happening on these floors. Now look at the way a car is getting manufacturing. I mean, it is a technology treat, if I may say, for the eyes to see the amount of technology that has got thrown into this to create a near autonomous industrial environment. And therefore, this is going to be the new norm. So when we look at a future industry which is going to churn out assets at the production level, uh, this is the new need. So each of them is an asset now. The shop floor roof is an asset. Every uh, piece of tool or test equipment put is an asset. Every activity which is being done in terms of any software or any hardware embedded uh, is a asset. Any app that is running on it is an asset. So really speaking, the definition of asset and the number of assets is increasing manifold. The pillar 4 is tools, and we have to look at tools. Specialization in tools is going to become very, very important with time. And therefore, when we look at upgrade and modernize technical infrastructure, tools is very important. And we just looked at the Dresden factory, where you can see robos, a lot of labor saving devices, a lot of project management structures which have come up, not only in terms of software, even in terms of adaptive floors, with a lot of software tools, with a lot of knowledge management, which is embedded into electronically, or if I may say, software based technical manuals, which are being autonomously or semi autonomously addressed, a lot of data analytics. And then when we look at this factory, that is one end of the spectrum. The other is when the car moves out or your product moves out, how do you carry out customer relationship is very, very important. And therefore, today you have this coming up as a separate industry to help you do the whole thing, whole asset management life cycle in a very, very organized manner. And you'll agree with me that when you look at such factories which we just saw, I mean, there is a need for us to look at upskilling and reskilling. So learning and development tools are going to become very, very important. And most importantly, when we look at visibility, I think social media itself is a tool, and therefore it becomes a very important part of asset management 5.0 strategy. Let's get to pillar 5. The pillar 5 is about test equipment. And when you look at any equipment or any asset, how do you test the asset? What are the parameters? What are the benchmarks? What are the milestones? And how do you test them at every stage? It becomes very important. So in a quest to upgrade and modernize technical infrastructure, I think minimum downtime with just-in-time maintenance interventions are very important for which all the test equipments play a huge role. Today, we've got something called Byte. It has been always there, built-in test equipment, Byte. And with time, it became part of automation. Today, it is part of autonomy or semi-autonomy. Soon, it will become part of full-scale autonomy. We'll have robotics, which will look at the whole thing. And miniaturization through nanotechnology and advanced material is actually putting a bite in every small thing. You have today a software on chip, you have a software on platform. And what is a chip? I mean, it's such a small thing, but you've got a software on it to give you the first thing it does is the byte. Then you have IoT connectivity, Internet of Things and connectivity, which will help the byte of A to check an item in B because both of them are talking to each other. So such like specialized test equipment will need to be are the norm, and if they are not the norm, they'll have to be built in. Like I said, big data driven um, analytics using huge amount of data. So big data means artificial and augmented intelligence will give you a very, very realistic, uh, predictive, prescriptive maintenance footprint. And when we look at augmented intelligence, analytics, I think augmented reality, virtual reality, we talked of digital twins is going to be very important. And then there is a need to whitelist such systems. So when we look at it from a quality perspective, a lot of software we are talking of, who will whitelist this software? We all know it has happened in the past, and I'll not name the factory or the company, but there were companies who showed something that they mutilated the data or they played around with data to show better efficiency. I mean, who will whitelist it? Who will make sure that there are no, should I say, bugs which do not give the true value of an asset? And therefore, that is going to be very, very important. And test equipment to that extent will be very, very important. And of course, customization and flexibility will be equally important. Getting to pillar 6 as a part of upgrade and technically modernize is about warehousing and logistic management. Because when you look at asset management 5.0, you have to look at everything. You have to look at the complete life cycle from home to tomb. So in this journey, we have to look at smart warehousing. That means the environment conditions under which an item should be there, the clean rooms, especially when you look at semiconductor based industries will be very, very important. You have to look at smart mobility when an item is moving from place A to place B. I mean, let's take an example. If you have to move, say, blood or an organ being donated, I'm just bringing in these examples only to bring in that an organ will survive no matter how much journey it has to do, only if it is given the right environment for transportation and mobility. And therefore, smart mobility will become very, very important with time. Advanced robotics. So today, a human being, when he picks up any item, he says, my God, this is spurious, I'm not going to use it. So you'll have to have advanced robotics who pick and decide on the condition based on expected performance. Even while packaging, they have to look at performance. Is it the right quality that is being packed? So really, that is going to be yet another technology value add when we look at the future. Unmanned autonomous system, whether it is drones, unmanned ground support, or driverless cars, as we call them. And then we will need asset information management and decision support system. After all, when we are having so much of data, it helps us in creating information management systems and a decision support system. So we'll have to look at enterprise resource planning, intelligent systems, knowledge management systems, all aiming towards precision and positioning of information, that the right information at the right place at the right time, in the right condition, at the right cost. They also help us in minimizing waste and maximizing efficiency, which is a very important determinant, will become more important with time. Then shelf life management. How do you make sure that asset or shelf life is managed well? I mean, every item has a ESL, expiry of shelf life. So to make sure that before a shelf life expired, it is put to good use will be very, very important. And if it is expiring, whatever intervention must happen, must happen. And then we look at green logistics, just-in-time maintenance, sustainability and optimization, and a circular supply chain, which is 4 Rs. 4 Rs is reuse, recycle, refuse. These are the three, and the fourth one is reclaim. Reclamation technology will play a major role in times to come, and on-demand manufacturing through 3D printing and other such initiatives will remain very, very important. So when we look at pillar 6 in terms of modernizations, we're looking at the warehousing and supply chain beyond production. Okay. Now let's come to the pillar 7, which is perhaps the most important. Having done all this, how do you look at enterprise readiness? What are the KPIs for enterprise readiness? Now we had these ISO standards which were defined 55,000X as we call them and 27,000 for software systems. I think there's a need to look at unified ISO standards. With the evolving landscape, we'll need to forecast, a good forecasting of what all we need to do. We'll have to study industrial trends, the technology trends, and advancements, global economy, and ecological priorities. I'm sorry, the spelling of priorities are wrong, but we'll have to look at this. Today, industries cannot absolve themselves of the geopolitics and the geostrategic considerations. Cybersecurity and info security management will continue to be very, very important. So we'll have to look at all this very, very realistically. And therefore, if I were to look at a unified ISO standard, we have to look at the womb to tomb value maximization and risk mitigation, which is the main purpose of these standards. We'll have to look at building in technologies, artificial intelligence, first the data and data protection regulation, and then artificial intelligence, IoT, blockchain, cloud, quantum. We'll be talking about it in the first part. We need to look at guidelines for asset life cycle management, big data analytics. These guidelines will have to be built. Like I said, it's very, very important to make sure we whitelist all this correctly through regulations so that no industry can misuse these to create a wrong impression or wrong impact or a wrong announcement for a customer. So the customer is always correctly informed. And then these standards will also have to build in the ESG, the environment, sustainment, and governance to include climate change and other sustainable best practices. Then we need guidance on valuation, risk management, and optimization strategies. New types of assets will come. How do we manage those new types of assets? I mean, I talked of quantum assets. Today we talk of digital assets. What about quantum assets? And another technology which may come up later. How do you ensure IPs, which is going to be a big challenge? And therefore, ISO standards from the way of industries, for inspections, for visibility, for whitelisting will remain very, very relevant and important. Also, let's look at, so we've looked at an industry or a geographical boundary. Let's look at globalizations. We are becoming a globalized world. The world, they say, is flat. How do we harmonize globalization standards? How will there be consistency, reliability, seamless operations, international operations? How will regulatory mechanisms of one country not affect the other? So how will we make them more open? How will compliances become more open, but at the same time adequately strict to meet global industrial specific standards? So this is going to be yet another challenge. And I think these are good areas for research with focus on adaptability, resilience, and globalization. Okay. Then in an overall analysis, we have to look at what are the key performance indicators for enterprise readiness. How do we build an enterprise readiness index? Is like technology readiness levels or business readiness levels? What are the enterprise readiness levels for asset management 5.0? How do we build these indices? How do we build the service level agreements for each of these? So this is going to be yet another very important consideration when we look at enterprise asset management 5.0. And in an overall analysis, life is going to become very different. I mean, we'll have decision support operation centers in industries, in government, in enterprises, in almost everywhere where you'll have dashboards, you'll have uh, screens which will actually talk and give you the right inputs, inputs to upskill, inputs on cloud and edge, and all this will be required. Data analytics, IoT platform, decentralized control system, SCADAs, safety, security, digital twins, smart sensors, 5G, and the like. So really speaking, the whole landscape of asset management 5.0, and these are just some very representative, salient pieces I've put in here. Actually, you could fill more and more into as number of concentric circles as you want to. And communication is also going to be very, very important because they're all going to speak to each other. Cognition is going to be very important. I talked of blockchain, modularization. So to summarize asset management 5.0, the way we look at it from a future, I think there are 7 key goals which we need to look at when we look at enterprise asset management readiness. The first is enhancing technology thresholds. The second, enhancing technical thresholds of skilled manpower because skill is going to be the new collar. Goal 3 is upgrade and modernize infrastructure. Goal 4, minimum downtimes, maximum uptimes, and just-in-time maintenance. With, when I say just-in-time, it is also predictive, prescriptive maintenance. Goal 5, we all are here to look at the customer. I mean, at the end of the day, asset is in the hands of the customer. You design it for the customer. The use is at the customer end throughout the life cycle. How do you design this to create what I am wanting to call customer ecstasy? Goal 6 is a unified ISO enterprise readiness standard. Goal 7 is recommendations for enhanced effectiveness. So I think what the industry needs to do is keep looking at it through recommendations for enhanced effectiveness. Goal 7, therefore, becomes a very important goal through the life cycle of every industry, every government. And therefore, if we are to look at the government, the CII, FICCI, and I've just picked up 2 agencies in India, the CXOs of industries, I think 2 very loud questions come up in an industry 5.0 environment. Who will do asset management 5.0? Is it a function of a coup? Is it a function of a CXO? Is it a function of a CFO? Is it the function of a CIO? Is it a function of who? Or all of them? Or do we need to designate one asset management 5.0 specialist who looks at the whole gamut, forecasting, planning, and executing end to end, door to door, home to toe? Who will audit and who will regulate? These are some 2 questions I want to leave with you with at this point in time. And therefore, the bigger picture is time has come to think and act. Look at disruptions in asset management and be prepared to learn, unlearn, and relearn. Thank you. With this, I come to the end. If there are any questions, I would like to answer them. So the life is going to be all about dreams, goals, and success, standing on pillars of leadership, people, product or service, communication, marketing, and organization. Questions, comments, please.
Thank you, General Kapoor, for that outstanding presentation. I have one small question. This is mostly about how secure, because what we are talking of is most of the digital uh, tools and software and artificial intelligence, machine learning. So how people, how or what are the challenges that we may face, likely to face? Because already, you have people accessing somebody else's uh, disrupting somebody else's websites, and there's all these things are already going on. And what kind of challenges could be there on the cyber security front?
Right. I think that's a very, very pertinent and important questions you've asked, and very, very relevant. When we look at the digital space and we look at the quantum space, whatever cybers, in fact, let me start by saying that every industry likes to be secure. The first level of security is the physical security. When you make any industry, you first make a boundary wall, you make an access gate, you have some system of access control. In physical terms, you do all this. But in the digital space, how electronically zeros and ones are moving, there is no visibility. And therefore, you have to use technology to create that visibility to see, is there any intrusion happening? If it is, how do you ward it off? And therefore, today we've got something called encryption of data. So you keep data at rest encrypted so that even if somebody comes in, he only finds a can of worms in data. He doesn't find anything meaningful because it's all encrypted. And you also encrypt data in motion so that anybody who tries to get into your pipeline and remove data also finds junk, because it's only end to end where encryption and decryption happens. So that is one good technology of encryption and decryption. But that said, when we come to some of these technologies, and as we come closer to quantum domain, we feel that all these cyber security uh, controls that are being exercised for security are going to get compromised, because all these mathematical models are going to get blown off very fast. It's like, if you have a nice wire cutter, no matter how good a wire is, as your wire cutter quality and strength goes on improving, you can cut any number of wires and get into any kind of system which is fenced by these wires. So in the quantum world, we'll have to look at newer technologies, and blockchain is one of them. I mean, we talk of blockchain technologies, and maybe when we look at quantum computing, we have to look at similar standards using quantum to create the next cyber safe environment. So it is going to be a combination of cyber defense and cyber offense. And when I say cyber offense, it is ethical cyber offense. That means you are ready with your weapons, that should somebody come in, you will act on him. And at any point in time, you also keep firing to tell them that, we are quite strong here. Don't. So therefore, I think when you look at a future AM 5.0 environment, I think cyber will have to become a very important armory, which today industry can ignore. It has the choice. Tomorrow it will be a compulsion. And if they didn't do it, they'll run into crisis from time to time. That's my take.
Thank you. Any other questions from the audience? Well, if there are none, I think I will request Mr. Satyesh Sinha to propose the formal vote of thanks.
Good afternoon, ladies and gentlemen.
I think you are on mute.
Are you able to hear me now?
Yeah, now we can.
Good afternoon, ladies and gentlemen, esteemed guests and respected dignitaries. On behalf of AMSI, I stand before you with the gratitude and a heart full of appreciation to Dr. Lieutenant General Anil Kapoor for a wonderful future-ready type of a technology presentation. First and foremost, I would like to express my deepest gratitude to Lieutenant General Dr. Anil Kapoor, AVSM, VSM, Vice President and Chairman, National Advisory Committee, AMSI, for taking time to share his valuable insights and knowledge with us. Here, I just take a little bit of time, and I would like to understand from Dr. Kapoor one thing is how he can think so very in future. That's one thing which we all want to understand from him, probably on a next webinar where when he is convenient to speak to us on that subject. Your presentation has enlightened us as well as has left us an indelible mark, sir. on our minds. Thank you very much for the speech. I extend our sincere thanks to all our distinguished guests, Dr. Raghuveer Pai, President AMSI, and other senior business leaders who have graced this occasion with their presence. Sirs, your support and encouragement mean a lot, but I would request all of us to speak and ask some questions such that the knowledge which is shared becomes crystallized in our minds, and probably we start thinking on them. One of them was the example what Dr. Pai had spoken of, the cyber security and the answers which we got from Dr. Kapoor. A special thanks to the organizing committee who have worked tirelessly behind the scene to ensure seamless execution of this event. Your dedication and hard work has been instrumental in making today a resounding success. I would also like to express my appreciation to all the participants and attendees. Probably, Dr. Pai, we would have to design some sort of methodology by which we get more and more people attending to these webinars, which are really interesting, and probably these are the platforms from where we can take a jump to the next level of technology and understanding of the technology. Probably we may have to work out on that. A special thanks to media and sponsors and partners for their support. Your commitment to this event is invaluable, and we are grateful for the collaborative effort that has made this event possible. Last but not the least, a big thanks to each and every individual who has played a role, big or small, in making this event a success. We are truly grateful for your efforts. As we conclude this webinar, let us carry forward the knowledge gained today, the connections made, and the inspirations received, plus the tweaking of our minds in thinking of the future. We look forward to the future collaboration and continued success. Thank you once again, and we hope to see you again at our forthcoming events. Have a wonderful afternoon. Thank you.
Thank you, Mr. Satish Sigma, for doing the honors of presenting the vote of thanks. Uh, yeah, I think all our efforts are there continuously to improve the audience. Um in fact, the webinar invite goes to many people, but I do understand that they may be having their own priorities. But yeah, our efforts, I think I would say that each one of us should be able to get at least two, three people from our own circle. I think that's one approach to improve the numbers. And I also thank Mahua Banerjee for introducing General Kapoor. And thank you, Lieutenant General Dr. Anil Kapoor, for the excellent presentation. And thank you all. We meet 1 month up from now for the next monthly presentation on the third Saturday of March. So thank you. In between, of course, we will be having our own activities, which from time to time will be communicating to you. Thank you.
Thank you. Thank you very much.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you. Thank you.